So welcome everyone, welcome to this lecture, and this lecture is very important for your CSIR Net exam as well as other exams as well, because this topic is a very frequently asked topic, canonical ensemble. So more than the basics of canonical ensemble, today we are interested in very quickly revising everything, and we are interested in the difficult portion of this topic, the topic which is asked and student usually feel trouble in doing it, right? So that is the scene we will have. So let's understand what is canonical ensemble. So one by one we will understand. So canonical ensemble is basically, ensemble word basically means a system, a photocopy of many systems. Okay. So rather than, so when I have a photocopy of many systems and I am basically doing the statistical mechanics means basically predicting the results when the sample size is very large. Okay. These are some of the basics. Canonical basically means that when your temperature is fixed, so your system's temperature is not changing. So how do you know when to use canonical ensemble? It is always when the temperature is fixed. Similarly, can anyone tell me when do we use microcanonical?
When
What is a,
energy is fixed. Energy
when
is fixed.
energy is fixed? Yes. So when energy is fixed. Okay. So when energy is fixed, or when we use microcanonical ensemble, we usually find something known as microstates, number of microstates. And once we know microstates, we find entropy. And entropy is found using k log of sigma. This is known as Boltzmann relation. So this is a recipe of microcanonical ensemble. But for canonical ensemble, my energy of a system is not fixed. My temperature of the system is fixed. And when my temperature of the system is fixed, what I try to do is I try to find a partition function, z. And once I know partition function, I can find all other quantities. All other quantities. So once your partition function is calculated, all other quantities you can easily find out. You can find, and I will give you the recipe. Basically, we need that recipe. Once I have a partition function, so how can I find all other physical parameters? Okay. So your system will usually be divided into two categories. Two categories. Number one, system wills. Ki your energies are continuous. Energies are continuous. Basically, your energy is increasing or decreasing continuously, right? And one is then your system when your energies are discrete. Discrete energies basically like in infinite potential well, quantum harmonic oscillator, and so on. Continuous energies means either in your free gas or ideal gas or in classical harmonic oscillator, and the systems like these in which your energy is continuous. Basically, it is a continuous function of x, y, z, and so on, momentums and so on. Okay. What you will see is that your energy, basically what we call it as Hamiltonian, will be the function of position as well as momentum, right? Because energy is made up of two things. One of it is known as kinetic energy and another of them is known as potential energy. You know, in kinetic energy, you have P square by 2m. And in potential energy, you can have something like half kx square, or you can have a into mod of x. Many such potentials are possible. So overall, your energy can be a function of momentum as well as position. There can be one momentum, there can be multiple momentum. Multiple momentum means, for example, if it is a p square, it is actually not p square, it is actually px square by 2m plus py square by 2m, so on. Similarly, you can have half kx square, half ky square, and so on. Simple. So when your energy is continuous, first of all, we need to learn that how to find partition functions when the energy is continuous. Then we will learn how to find partition function when your energy is discrete. Okay? Energy is continuous, then how do you find partition function? Energy is discrete, in that case, how do you find partition function? Right. There are some, I can say, some very, you can say, is common systems which we deal with. That also we should know. Common systems that we deal with in continuous is ideal gas. or classical harmonic oscillator, okay, or paramagnetism, right? In discrete systems, we deal with quantum harmonic oscillator, or we deal with the two energy systems, which can be think of it as lasers and so on. I hope you are all writing it down. Okay, so these are some of the systems we need to use. The most problematic thing is this: how do you find the partition function when your energy is continuous? This is not that problematic. This is doable. This is simple, little bit simpler, and this is most of you might also know. So that is the first part of the lecture where we understand that how do we find the partition function. Okay, let's say we find partition function. Once our partition function is on the table, then how do we find the other physical quantities? Okay, so other physical quantities are found using a recipe which I'm going to give, and you need to note it down. So number one physical quantity is average energy. So how do you find average energy? So average energy is found using minus curly by curly beta log of z. Now what is beta? Beta is given by 1 by kBt. Kb is a Boltzmann constant, T is a temperature. Beta is a constant because in canonical ensemble temperature does not change. So hence beta is also not changing. Okay. So that is your average energy. So this is how you find average energy. Once you have average energy, another physical quantity that you find is known as Helmholtz energy. Helmholtz energy, or A. We also call it as free energy. So once you can find free energy also, and that is given by minus kT into log of z. Okay. Once you have A, you can find all other physical parameters. For example, entropy. Entropy can be found using minus curly A by curly T. Because once you find free energy, you can find your entropy by using minus curly A by curly T. Okay. Similarly, you can find pressure. Pressure can be calculated using a formula minus curly A by curly V. Okay. And then let me add the page here. Sorry. So let me add a page here very quickly. Yes. Okay. And then you can find entropy and you can find pressure, and then you can also find nu. Can anyone tell me what is nu? Very quickly. Yeah. Chemical
Fugacity.
potential. Huh?
Chemical potential.
Chemical potential.
Chemical potential. Right. So chemical potential is calculated using curly A by curly N. So these are the few terms that you can directly find once you know the A. So what I did, first of all, I need Z. Z is what? Z is known as partition function. Once I know Z, I can find average energy, yeah, by using the formula given by this. I can use Helmholtz free energy, which is given by this. Once I know Helmholtz free energy, I can find entropy, pressure, chemical potential, and so on. These are the three basically they will be asking you. Okay. Another interesting fact is that if your system has n particles, and you find the partition function for just one particle, you find this a partition function for one particle. For n particles, all you need to do is raise to power n. Okay. So you don't have to write a full Hamiltonian for all the particles. Instead, all you need to do is use it to find the partition function for one particle, and then raise to power n, you will find the partition function for n particles. Okay. Other than that, one very interesting integral also we use in this theorem. Z1 is a partition function for one particle. Listen very carefully. One particle. Okay. And this is a partition function for n particles. Okay. Perfect. Now, another very interesting integral that we use in our theorem, in our questions, is that this. Can anyone tell me what will be the value of this? Yes.
Root pi by alpha.
Root
Under
pi
root.
by L. Very good. So this integral, you will be using it a lot. So everything I have written so far, yes, any doubt in that? If you have, go ahead. It is just the basic concepts I'm giving you,
Sir.
which we will be using. That's all. Nothing I have done so far. This is a
Sir.
list of formulas that we might be needing. Yeah. Everyone done with writing it? You need to write it. These are very important.
Yes, sir. Written.
These
Sir,
are very, very. Yes, go ahead.
the partition function for the n particle, what I have studied earlier, it is only valid for perfectly valid for the Maxwell-Boltzmann, na? And then for fermions and
Classically, we are in classical statistics.
okay,
The
okay, sir. Okay, yes, sir, definitely.
Okay. Chalo. Next, let's understand now. So let's come to very quickly to our systems. Right? So we have continuous energy systems, which we need first of all, continuous energy systems. In continuous energy system, how do you write partition function? So the partition function, first of all, is written by 1 by h bar to power d. And this I am writing for one particle only. Okay? So I am writing my partition function for one particle. So it is h bar to power d. D is a dimension. If it is one dimension, you put 1. If it is 2, you write 2. If it is 3D, you write 3. Okay? Then you do some integrals. Okay? There can be many integrals. I have only mentioned 2 here, but there can be more than 2. I will explain you. And then e की power minus beta h into dq, or you can say, okay, dnq and then dnp. Okay? This is the situation. So let's understand what I have done. What I have done here. So let's say you are in one dimension. You are in one dimension. So your Z1 becomes 1 by h bar e की power minus beta h into dx. Simple. Because you are in only in one dimension, so it is only dx. And this will become e की power minus beta h into dpx. Simple. But let's say you are in two dimension. Then Z2 becomes, क्या कह रहे हैं आप? Here we have h. Okay, इसका कोई फर्क नहीं पड़ता. h लिखो, h bar लिखो. ठीक है? So you are saying that here h should be there or h bar should be, does not matter. In most of CSIR net questions, not even h bar will be there, no h will be there. In some questions there will be h bar, then in some questions there will be no h bar. ठीक है? Or that does not matter here. ठीक है? Both of them are correct. Don't worry about this parameter. It will be there in some questions. Don't assume that it will not be there. Okay? But it is not an important factor for us. Okay? But we will go for it for now. 1 by h bar square, okay, for two dimension. Now in this case, e की power minus beta. Basically, I have written e की minus beta 2h twice, so that is wrong. So I need to do like this only. That is wrong. I only need to write it once. E की power minus beta h dx into dpx. Okay. Similarly, e की power minus beta h. If it is two dimension, then you will have dx into dy into dpx into dpy. And now you can easily assume. Now you can easily assume for three dimension. Sorry, for three dimension. For three dimension, you will have, ठीक है, e की power minus beta h dx dy dz dpx dpy dpz. ठीक है, dpz. So basically these are 6 integrals. 1 2 3 4 5 6 integrals. Similarly these are 4 integrals. Similarly these are 2 integrals. ठीक है. So this is how do you write your partition function for one particle in case of what I can say classical or you can say continuous energy systems. Please note this down and then we go for the questions. Yes, any doubt here? In some questions, if you don't find this h bar, don't worry too much. If you find this h bar, then also it is okay. None of the question will be problem for you because of this h bar. That you have to understand. Okay. Yeah, everyone, can I move to the numericals? Yes. Everyone ready for it?
Yes, sir.
That is the main game. Okay, so now we are moving to the numericals. If someone is lying on the bed looking at it like a movie, so wake up, have your notebook ready. You need to solve the questions with me. Okay, so first question we will do very slow, very well. Every step you will also do with me. And the next questions we will do fast. So let's begin. Let's begin. Okay, so this is in general the formula I have written, and this is a thing that we need to keep in mind, that partition function for n particles is equals to partition function for one particle raised to power n. Okay. So let's do like this. Let's do here only. So let's solve a very sorry. Let's solve a very
Sir,
famous problem.
sir, but in case of indistinguishable particle, we divide it by n factorial.
Sorry, in case of
Indistinguishable particle, like partition function for n
indistinguishable
particle.
particle means you are in quantum statistical mechanics. Why you are complicating for yourself? You are in classical stat mech, bro. No. Have you ever seen any problem in which they ask to find partition function for electrons, neutrons? Quantum stat mech we did yesterday. Remember? When the particles are distinguishable, you are in classical stat mech. We are in classical stat mech. Okay, perfect. Let's go on. So we are now dealing with ideal gas system. Okay, ideal gas system. This is one of the good example to understand the things. So for ideal gas system, there are n particles, let's say in a gas. Okay. How do you write the Hamiltonian? First of all, do I need to write the Hamiltonian for all the particles? No, I need to write an partition function for only one particle. So my Hamiltonian will be kinetic energy plus potential energy. Can you tell me, is there any potential energy in ideal gas? Do we have
No,
potential
sir.
energy in ideal gas? No. Ideal gas basically means that there is no interaction between the particles. So potential energy is zero. Only kinetic energy we have. So let's say the particle, in general, the gases are in 3 dimensions, right? Gases are in 3 dimensions. So what I can write is px square by 2m, py square by 2m, pz square by 2m. So this is your Hamiltonian. Now let's write partition function. Partition function is 1 by h bar cube because it's a 3 dimension. Then I have 6 integrals and I have something like this: beta px square by 2m, e की power minus beta py square by 2m, and e की power minus beta pz square by 2m. ठीक है? And then I have dx, dy, dz, dpx, dpy, dpz. In general, what I had was e की power minus beta h. ठीक है? And you know, when the bases are same, powers add. That is what I have done. I have just split my exponential into 3 parts. Now what I need to do is, I just need to split the integrals. So one of my integral will be e की power minus beta px square by 2m into dx. My momentum, sorry, not dx, dpx. And my momentum will go from minus infinity to infinity. Similarly, minus infinity to infinity, e की power minus beta py square by 2m into dpy. Perfect. And then similarly, minus infinity to infinity, e की power minus beta pz square by 2m dpz. ठीक है? And then I will have 3 integrals minus, sorry, तो dx, dy, dz. These are my 3 integrals. Can anyone tell me what is this? Directly, what is this?
Volume.
cube.
Volume. So this is volume. Okay, very nice. So volume thing I multiply here, h cut cube. What is this? What is this? Can you relate with the important integral I gave you? Minus infinity to infinity e की power minus alpha x square into dx. And the answer to that was pi by alpha. Remember? And in this case, alpha is what? In our question, what is alpha? In our question,
Beta
alpha
by
is beta by 2m. So if I do that, I will get v by h cube is as such 2 pi m by beta. Or you can say v by h cube 2 pi m kbt. ठीक है? Similarly, I get for this, I get for this, and I get for this. Because there are 3 integrals, right? For all of them, I get the same answer. That is why I need to do cube here. ठीक है? I need to do cube here. So if I do cube, I get 3 by 2. ठीक है? So this is how I find the partition function for ideal gas. Is it clear to all of you? Yes. Clear to all. Perfect. जल्दी करें. This was a simple. this में अभी no numerical we have started. ठीक है जी? No numerical we started. This is what you have to do. So this integral now I will remember. ये इंटीग्रल को याद कर लो, अभी कर लो, because in all the questions this will be repeated. So इस इंटीग्रल की वैल्यू क्या आई है? The value of this integral is 2 pi m into kbt का under root. This is the value of this integral which has came. Okay, or you can even write 2 pi m by beta. ठीक है, चलो, let's go for question 1. So this is your question number 1. Very interesting, not very difficult, but good quality question to begin with. A particle is confined in a region x greater than 0. So your x can be greater than 0 by a potential. So potential is given. So basically your system has some potential. What is a mean position? Forget about mean position. First of all, we have to find what is a partition function. So let's first find what is a partition function. H bar you can write, H bar you cannot write, H bar square you can write outside, you cannot write outside. That is completely up to you. Okay. So how do we write partition function? So partition function. Now, first of all, we need to define, is it 1D, 2D, 3D? So obviously it is given, it is a one-dimensional problem. Only X is involved. So if only X is involved, I can say my Hamiltonian is given by Px square by 2m plus potential energy, which is U naught X plus U naught X. And then my partition function can be written as Z equals to 1 by H bar. You can write H bar or you can avoid H bar. Let's avoid H bar. No problem. Both are fine. Okay. Then your double integration e की power minus beta h, one is dx and one is dpx. Okay. In this case, I am not writing dpx because there is only one parameter. So either you write dp or you write dpx, same thing. Then I put my value of beta. When I put the value of beta, again power same, basis same, power add wala situation. So I have split my integral. Okay. So one contains u naught x term and one contains px square by 2m term. Okay. Px square by 2m term. So basically I can do that. Once, whenever we have exponential a plus b, so whenever you have e ki power a plus b, you can write it as e to power a and e ki power b. That is exactly what I have done. So I have split the integrals. One is for x and one is for px. Okay. Again, I'm not considering h bar, so remove it. Now x is going from 0 to infinity. This is given. Why not minus infinity to infinity? Because it is given that your x is greater than or equal to 0. That is why I am taking that my x goes from 0 to infinity. Similarly, my px goes from minus infinity to plus infinity. Because let's say your particle is from 0 to infinity. Now your particle can be moving towards right hand side or your particle can be moving towards left hand side. So if your particle is moving toward right, it is positive momentum. If it is moving toward left, it will be negative momentum. Although your particle is between 0 to infinity, but the momentum can be right or left. Both is possible. That is why momentum is from minus infinity to infinity. इस इंटीग्रल का वैल्यू व्हाट वी डू रिमेंबर, हमने याद कर लिया ना, वी मेमोराइज्ड इट. तो क्या बन गया वो 2 पाई m बाय बीटा का अंडर रूट. वही आ गया सेम का सेम. नाउ यू ऑल टेल मी, क्या मैंने ये इंटीग्रल सही सॉल्व किया है? ऑल ऑफ यू सॉल्व एंड टेल मी, इज इट करेक्ट? बेसिकली यहां तक इज इट करेक्ट? एवरीवन सॉल्व. आप करें, खुद सॉल्व करें एंड मैच द आंसर. yes, everyone agrees with me कि ये मैंने सही सॉल्व किया है. तो फाइनली आई गॉट द पार्टीशन फंक्शन. I got the partition function. But in this question, they were not asking for partition function. They were asking for mean value of position. Okay, mean value. So let's also learn how to find mean value in any question. So if you have to find mean value in any question, all you have to do. So let's say I want to find mean value of x. So what I will do is I will divide by z, which is my partition function. And then I will multiply my x thing and then e की power minus beta h, and then similarly all the integrals will come. So if it is one dimension, dx into dpx. If it is two dimension, dx into dy, dpx into dy, dpy. ठीक है? So mean of position is only thing that I have changed is that I have multiplied whatever quantity जिसका mean मुझे चाहिए. So if I need the mean of a, I will multiply a here. If I need the mean of x, I will multiply x here. Rest everything is same. And then I also need to divide by partition function. So please put this formula in bracket and in your notes. In your notes, put this formula. Okay, put this formula. Yes. So now let's try to solve it out. 1 by z. So z ki value I have already calculated. I will use this value of z in the end. जब पूरा क्वेश्चन हो जाएगा, I will use this value of z. Then x, you have x here, so I have x here, e की power minus beta h, e की power minus beta h into dx into dpx. Again the same logic, since it is one dimension, so dx into dpx. Second logic, I need to split my exponential. Let's split. Again I am splitting because my Hamiltonian is given by p square by 2m plus u naught x. So one will be e की power minus beta u naught x and one will be e की power minus beta p square by 2m. But now in with this x will get multiplied because this x is here. ठीक है, इसका तो इंटीग्रल मैंने याद कर लिया है. I have memorized the integral of this, so that gives me 2 pi m by beta and z is already there. इसका इंटीग्रल मैंने यहां सॉल्व किया है. Everyone tell me, is this correct? आप सॉल्व करके देखिए. Have I done it correctly? Have I done it correctly? Please tell me that if I am correct. ये जो है बेसिक क्लास 11 12th इंटीग्रल्स आर देयर. इसके अंदर मैं डिटेल में नहीं जाऊंगा. You must know this. I-late rule you must know how to apply. Right? Please tell me, is it correct? Everyone. There are many people. Yeah. Okay. So this integral you can solve and I get this answer. Now what I have done is I have put the value of z. मैंने z की वैल्यू डाल दी. If you see what is the value of z, so there is 2 pi m by beta. So 2 pi m by beta and 2 pi m by beta gets cancelled out. And then there is 1 by beta nu naught in denominator. So that will get in numerator because 1 by z, na? So beta nu naught will get in numerator. So beta nu naught is in numerator. And from here I have beta nu naught square. Beta nu naught square and beta nu naught cancels. I just get beta nu naught, which is kt by nu naught, which is option number A. So is this question fine with everyone? क्या ये सबको समझ आया मेरे दोस्तों? My friends, is it clear?
Yes, sir.
Everyone actually. Yes, go on. Yes, please. Yes, Del, your voice is not there. Okay. So how will you revise this stuff? So once this lecture is done, so what will you do is you will have one sheet of paper. In that sheet of paper, you will write all the numericals, whatever we discussed in the class. And then very quickly in 30 minutes, you will try to solve them all by yourself and try to get the same answers. So once you do this exercise, that is what we call it as a good revision. Okay. Chalo, next question. A gas molecules of mass m are confined in a cylinder of radius r and length l. So now your chat box should be open with you. I will be asking you some questions. So a gas molecules are there and it is confined in a cylinder of radius r and length l. Radius is much greater than length and it is kept vertically in Earth's gravitational field. So cylinder is kept like this. The average energy of the gas. So whenever you have to find anything, in this case they are asking you average energy, basically U. And as you remember, U is given by minus curly by curly beta into log of Z. So in order to find U, first you need is a Z. First you need is Z. Okay? The average energy of the gas at low temperature means, and they have even given that ki MgL means potential energy is much greater than thermal energy, which is kBT. So you tell me the average energy. So in order to find average energy, first you need is a Hamiltonian. So Hamiltonian will be potential energy plus kinetic energy. Kinetic energy is P square by 2m. Perfect. And here we have mgz. Now the first question. This P square by 2m, is it one dimensional or three dimensional or two? Yeah. 3D. Right? You are in a cylinder. So you can move any direction. But potential energy is one dimensional because mgh only, right? Because potential energy is only mgh. So this P square by 2m can actually be written as Px square by 2m plus Py square by 2m plus Pz square by 2m. So basically the problem that I am solving is three-dimensional problem, not two-dimensional problem. Again, h cut cube you can multiply or you can avoid. ठीक है, आई शुड हैव अवॉइडेड itself because in one of the book which I saw there was h cube, but anyway, ठीक है. So again you know how do you write e की power minus beta h. There are 4 terms, and I will also tell you what is a silly mistake which students make. So there are 4 terms, so I can again split. So I can write e की power minus beta px square by 2m and then into dpx, then e की power minus beta py square by 2m and then dpy, then similarly e की power minus beta pz square by 2m into dpz, and then e की power minus beta mgz into dz. People usually end here. No, you also have x integral and y integral. So then integration of dx and integration of dy. ठीक है, because you know when you're in 3D, dpx, dpy, dpz, dx, dy, dz. So you cannot forget dx, dz. There is nothing in exponential, so you can write e की power 0. E की power 0 basically means 1. So dx, dy should also be considered. ठीक है. Now limits are very important. Momentum can go from any minus infinity to plus infinity. Okay. Z is a height. Height can go from 0 to L, and x and y can go from 0 to radius. Right. So 0 to radius, and that is your integrals. क्या हमें इसकी वैल्यू याद है? Yes. Do
Sir,
we
should not
remember
it be
this?
minus r to r?
Will it be minus r to r? कैसे?
Sir, because we are considering x and
रेडियस क्या होता है सर? अरे प्रभु, रेडियस क्या होता है सर? आप 0 से r तक जाएंगे ना,
yes,
कहीं भी चले जाएं 0 से r ही जा रहे हैं.
the extension for dx, and because since we have considered in x and y coordinate to
माइनस r
x,
to r होना चाहिए.
because sir अगर origin में सेंट्रल कहीं पे लेता हूँ, सेंट्रल एक्सिस पे.
चलो छोड़ो, ये छोड़ो,
Okay.
ये छोड़ो, ये करते हैं, ऐसा करते हैं, सिंपल खत्म ही कर लेते हैं. dx dy, क्या ये चीज एरिया होगा?
yes sir,
विल दिस
pi r
एरिया?
square.
एरिया क्या होता है? पाई आर स्क्वायर. इसको आप पाई आर स्क्वायर पुट कर लेना. ठीक है, कोई बात नहीं, एंड में वी विल पुट इट एज पाई आर स्क्वायर. एरिया हो गया ना. ठीक है, वो सब का कोई मैटर नहीं करता. ये चीज वैसे भी कांस्टेंट नंबर देने वाली है, पाई आर स्क्वायर कर लो. ठीक है, बाकी 0 टू r भी कर सकते हैं, कोई ऐसा कोई मुझे नहीं लगता कोई दिक्कत होगी.
Sir,
चलो ठीक है,
we
इसके
should
बारे में नहीं ज्यादा सोचते हैं. हो सकता है, मैंने इतना सोचा नहीं इसके बारे में. गुड क्वेश्चन एक्चुअली यू हैव, आई विल बी ऑनेस्ट विद यू, बट सम सोचना पड़ेगा. बट लेट्स फाइंड एन आंसर एंड देन थिंक कि हमें सोचना चाहिए भी इसके बारे में या नहीं. ठीक है, ओके. इसकी वैल्यू वी रिमेंबर. व्हाट इज द वैल्यू ऑफ दिस? 2 पाई m बाय बीटा. अगेन वही बार बार सेम वैल्यू रिपीट हो रही है. दैट इज व्हाई दैट इंटीग्रल वाज वेरी इंपॉर्टेंट. 2 पाई m बाय बीटा. सो नाउ इसका भी आंसर 2 पाई m बाय बीटा, इसका भी आंसर 2 पाई m बाय बीटा, under root of 2 pi m by beta. That is why you see it is coming 3 times, so it is cube. यहाँ से I have written r square for now, r square, and this is what I have to find. This is what I have to find. So do you all agree that I have done the integration correct here and then correct here? इसको बाद में देखना. Yes, agree with me? h cut cube you can avoid for now. कर लिख भी सकते हैं, avoid भी कर सकते हैं, कोई मैटर नहीं करता. Yes, is it correct here? Yeah, this integral everyone is able to understand it. Yes, here I use the little bit of logical brain. Logical brain says that mgl is much greater than kbt, so this thing is almost zero. The reason being because the numerator is very big, sorry, the power is very big, and e की power many very big power will be 0. This thing is very big because mgl is much greater than kbt, so this thing is very big, and e to power minus very big number. सर इंटीग्रल के अंदर dx dy dz होना चाहिए, तो होना चाहिए, किया ना. dz यहाँ आ गया, dx dy यहाँ आ गया. राइट स्नेहा? तीनों लिए. आई टुक ऑल 3. ओके,
dx dy should be equal to pi r square. Now you didn't take pi r
कर लो
square
यार,
here.
पाई लिख लो. तुम्हें पाई लिखने का मन है, लिख लो, कोई फर्क नहीं पड़ेगा उससे. ठीक है, हो सकता कुछ भी हो. लेट्स से इसका आंसर बी है. चलो छोड़ो, इसका आंसर बी आ गया, वो भी लिख सकते हैं, कोई प्रॉब्लम नहीं. ठीक है, चलो नेक्स्ट बढ़ते हैं आगे. तो व्हाट आई सेड दैट कि दिस थिंग विल बी 0, है ना. तो दिस एक्सपोनेंशियल थिंग विल बी 0 बिकॉज ई की पावर माइनस इन्फिनिटी विल बी 0, क्योंकि ये चीज इन्फिनिटी जा रही है. वेरी बिग है ना. सो इसको आई कैन इग्नोर. नाउ आई कैन थिंक अबाउट माई नेक्स्ट स्टेप. मतलब हाउ डू यू मेक कैलकुलेशंस इजी इन एन एग्जाम, दैट यू नीड टू लर्न. I am now thinking about my next step. What is my next step? My next step is that I have found the partition function for one particle. So for n particles, my partition function will be z1 की power n. ठीक है, वो that is only raised to power करना है. ठीक है, उसको नहीं भी करोगे तो कोई बात नहीं, because only n factor will be depending. But my next step is to find average energy, and average energy is minus curly by curly beta into log of z. So I need to take log of z, and in this z, only one parameter matters to me, and that parameter is beta, because I need to take a differentiation with terms of beta. Only one parameter matters to me, that is beta, and other parameters are like a constant for me. ठीक है, so that is why what I have said is that okay, ये तो zero हो गया, इसको तो you can leave, तो इस चीज को आप भूल जाओ, because this is 0 and 1 minus 0 is 1, so this is simply 1, so this is gone. Look at here, all the other constants I have called it as any constant a, so you can call anything any constant a, and I'm only focused upon beta. So one beta is here and one beta is here, so this is beta ki power 3 by 2 and this is beta ki power 1, so you will get beta ki power 5 by 2. So in simple terms, what I can do is I can write my partition function as some constant a divided by beta ki power 5 by 2. So that from here on, my calculation for energy becomes very simple. Okay. So once this is done, now you write partition function for n particles. So that will be a ki power n by beta ki power 5n by 2. Okay, that is also okay. Now you do log of z, because I need to do the differentiation of log of z. If you do log of z, can I write log of a of n minus log of beta ki power 5n by 2 and log of a of n minus 5n by 2 into log of beta? How many of you agree with this कि ये मैंने जो लिखा है सही लिखा है? Yes. This is Zn. You know the log properties. Log a by b is log a minus log b. So first I use log a minus log b. Okay. And then you also know that if there is some power, it comes ahead. So if there is power 5n by 2, that will come ahead, and this is what you have. So the last step is to do differentiation with respect to curly by curly beta. तो यहाँ पे तो कोई beta है नहीं, there is no beta here, so इसका differentiation will be 0. And here you will have minus 5n by 2 and log beta का differentiation होगा 1 by beta. That's all. 1 by beta will be the differentiation of log beta. ठीक है? So this is your curly by curly beta of log of z, which is minus 5n by 2 into kbt. Now what is your average energy? Average energy is minus of curly by curly beta into log of z. तो minus अगर इसके साथ लगा देंगे तो you will get 5n by 2 into kbt. Done question? So that is why I was not too much worried about कि इसका आंसर क्या आ रहा है, because इसका आंसर whatever the answer is coming, that is going to get hidden in this a. And ultimately you see that when you differentiate log of a, that is going to get 0. तो उसके बारे में सोचने की इतनी requirement नहीं थी. ठीक है, right? Everyone clear with this kind of questions? So we are setting up the equation. Once we set up this equation, any difficult question comes. This is one of the most difficult questions. Okay, if you go on and try this question on your own, you will understand that this is a difficult problem. One of the difficult problems of canonical. Okay, so yes. Okay, I will take a 5-second pause here. Anyone has a doubt, please. यहाँ पे.
Hello, sir.
Yes. Yes, Arun.
Am I audible?
Yes, you are audible. Yes, Arun, you are audible. Tell me. Okay. खुद से करते हैं तो स्टार्ट नहीं करते. तो स्टार्ट करना ही बड़ा इंपॉर्टेंट होता है. स्टार्ट करने का मतलब होता है कि ये इक्वेशन जिसको सेटअप करना आ गया ना, दैट इज व्हाट आई टॉट. दैट इज व्हाट आई टॉट, वही करना है। तो your fear will go if you will follow my technique. घर when you are done with the lecture, on one sheet of paper write all the numericals, then open up your timer of for 30 minutes, solve all the questions again. So once you do that, your fear will be gone. ठीक है,
हेलो
चलो
सर,
नेक्स्ट।
एम आई
यस
ऑडिबल ना?
गो ऑन। हाँ टेल मी अरुण क्विकली।
हाँ सर। सर मैंने ये पूछना था, जैसे कि हमने इस क्वेश्चन में भी, सेकंड में भी एवरेज एनर्जी निकाली और क्वेश्चन नंबर 1 में भी एवरेज एनर्जी निकाली थी। दोनों में फॉर्मूला हमने अलग अलग यूज किया है।
कहाँ यूज
तो
किया
सर,
अलग अलग?
सर जैसे
अलग
कि
अलग कहाँ
इसमें
यूज
सेकंड
किया?
वाले में
पहले
हमने
में तो एक्सपेक्टेशन वैल्यू निकाली, राइट?
हाँ ये सर।
एक्सपेक्टेशन वैल्यू
सर जैसे
निकाली।
कि,
हाँ हाँ
लेकिन एक्सपेक्टेशन वैल्यू भी एवरेज एनर्जी ही होती है ना सर अल्टीमेटली?
हाँ, ठीक है होती है। तो यहाँ पे फिर ई
तो लेकिन,
लिखोगे, मतलब यहाँ पे तुम एच लिखोगे, है ना? एच लिखोगे ना।
हाँ सर।
तो फिर एच लिखोगे तो वो इंटीग्रल को सिंप्लीफाई करोगे तो वो यही बन जाएगा ना जो स्टार्टिंग में फॉर्मूला दिया। तभी तो फॉर्मूला दिया कि सर अगर आपको एवरेज एनर्जी पूछ लें तो आपको ज्यादा नहीं करने की जरूरत है, यही करो सीधा। समझ रहे हो मेरी बात? तो बात वही है, अगर तुम एच लगाओगे ना यहाँ पे, इफ यू पुट एच हेयर,
यस सर।
अगर आप एच पुट करेंगे यहाँ पे तो आपके पास फॉर्मूला वही बनेगा जो मैंने आपको दिया है बुक्स में, वो
ओके, अगर हम
डायरेक्शन।
वहाँ पे जेड की जगह ये वाली चीज रख देते हैं डायरेक्ट, तो वही
यस
बात बन जाती है अल्टीमेटली।
यस 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 यस।
ओके सर।
Okay, third question. A system of n particles, classical particles, each of mass m is two-dimensional. Two-dimensional harmonic oscillator is there. So two-dimensional harmonic oscillator potential is given. So basically you are in two dimensions. So how many of you are willing to do this question? Homework दे दें भाई. So this will be
Yes,
your
sir.
homework.
Yes, sir.
ठीक है? Nothing difficult. Okay, a gas of non-relativistic classical particles in one dimension. Perfect. Is subject to the potential alpha x. इसको कैसे डील करोगे? So if you are at x greater than 0, potential will be ax, and if you are x less than 0, potential will be minus ax. So when you are solving this integral, or you can even simply do, what you can do is, this is an even function. This is an even function. So rather than finding integral from minus infinity to infinity, you can multiply by 2 and find the integral from 0 to infinity. ठीक है? तो क्या ये क्वेश्चन करोगे? Can we give it as a homework? Yes. सिंपल है. Can you all do it? Yeah, done. ट्राई करें. Okay, next question. Okay, let's do this one. This one we can do. Consider n classical particles. N particles हैं in a two-dimensional box है. Box means what is the potential energy? What is the potential energy inside a box?
0.
0. Inside a well, inside a box, inside these things, the potential energy is 0. So what we do is, first we write for one particle, then we write for n particles, and then we find entropy. Okay? Entropy. So how do we do it? First we do for one particle. For one particle, Hamiltonian is given by p square by 2m. Then I write z. We are in two dimension. So this is actually not p square, it is px square by 2m plus py square by 2m. So I can split my integral dpx square by dpy square and then dx and then dy. Okay? And then I solve this out. All of you can solve this out, and then I got it. Okay? So now they are asking you the question in terms of energy, although they are not giving you the energy, they are not asking the energy directly. Okay? Sir, what I observed is, when the gas is confined, then the limits goes from 0 to infinity instead of minus किसकी limit sir? किसकी limits? Momentum की, position की, किसकी limits? Right? वो पता करो ना पहले. पोजीशन की लिमिट आप -L/2 टू L/2 भी पुट कर सकते हैं, 0 से L भी पुट कर सकते हैं. व्हेन इट इज कन्फाइंड इन अ बॉक्स, तो बॉक्स तो 0 टू L होगा ना, या फिर -L/2 टू L होगा, तो 0 टू L करना ज्यादा इजी है. ठीक है? व्हेन इट इज कन्फाइंड इन अ पोजीशन, तो इट विल बी बिटवीन सम, जैसे सिलेंडर में 0 टू L था, रेडियस 0 टू R था. In this case, it is a box of side L, so it is again 0 to L. So that is the situation. Okay. So in this case, I also need to find energy. Although they are not asking me energy, they are asking me entropy. but I need to find energy. The reason being because they are asking me entropy in terms of energy. In terms of energy, they are asking me. That is why I also need to find energy. So energy, how do you find energy? Energy is given by minus curly by curly beta into, sorry, यहाँ पे थोड़ा सा गलत है, log of z. ठीक है, log of z. And again, you see, I am using the same trick. Once I got my z, all the constant terms I am calling it as a, and beta I am only keeping. So again, I use the same logic and I find energy. My energy is here. The similar logic can be useful in finding Helmholtz free energy. Why I am finding Helmholtz free energy? Because they are asking me entropy. And what is entropy? Entropy is minus curly A by curly T. So in order to find entropy, I first need to find A. So in this, you see, this is a long question. First, you have to find energy. First of all, you need to find partition function, which is simple. Because by this time, you know all the values already. You know the value of this, you know the value of this, you know the value of this, you know the value of this. Partition function is a 5-second thing. Then energy is another 10-20-second thing. So energy, you know, curly by curly beta log of z. And now you know the trick that you know don't need to carry all the constants. Just call the constant A, and then your stuff will get easier. Once you know the energy, then Helmholtz free energy or free energy, that is minus kBt into log of z. So then you find your Helmholtz free energy. And once your Helmholtz free energy is there, the final step is to find entropy. Entropy is minus curly A by curly T. So you take the differentiation of this, you get the answer. Once you get the answer, still the answer is not done, because now you have to convert your temperature in terms of energy. वो कैसे करेंगे? Because the answer is not asked in terms of temperature. You see, answer is not asked in terms of temperature. The answer is asked in terms of energy. So where I find the energy, you see, this was the energy I found. So what I will do is I will put my kBt in my final answer, kBt, as E by capital N. So that is what I have done here. I have put my kBt as E by N. Okay, and that will give me answer. And there are other terms also in my answer, but that is fine. I don't need to consider these other terms, because if you read the question carefully, they are asking you entropy apart from additive constants. So they are also mentioning that in your final entropy, there will be some additional constants also which will be adding. You don't have to consider them. Apart from additional constants, which of these options are matching? So I matched with option number A. So this term I am getting, and these are my additional constants. So what was my first step? Partition function, then Zn, then energy equals to minus curly by curly beta into log of z, then kBt into log of Zn, and then entropy minus curly A by curly T. So long question. So this was little bit a lengthier question. But is it clear to all? You will try this out once, maths by yourself. You are confused that you have to find Z1 or n particle Z1. So the question gives you the hint. मतलब क्वेश्चन देख लो ना, ऑप्शन में n है, यस ऑप्शन में n है तो n पार्टिकल, इफ नहीं है तो दे डोंट वरी, देन दे डोंट केयर. एनीवे बिकॉज ऑफ n होगा क्या? यू विल ओनली गेट अ मल्टीप्लीकेशन विद n, और तो कुछ भी नहीं होना. ठीक है, तो इसमें इतना टेंशन की जरूरत नहीं है. राइट, चलो. Okay, now this is very important. Everyone stop your work and come to me. Okay, this is very important question, difficult question, and this is something you need to learn. How do you solve such integrals? ठीक है, इसमें we will use Gaussian technique to solve the integrals. So Hamiltonian is given. It's a two particle system. Two particle system is given. You can either think of it like a two particle system or two dimensional system. मतलब either you can say two particles are in one dimension, or you can say it is a one particle in two dimension. It's the same thing. Yeah? Think about it. Two particles in one dimension and one particle in two dimension is same thing. You need two parameters. In this you will say P1, P2. In this you will say Px, Py. Just two parameters will come. So the same thing. Yes, all of these questions are PYQ. None of the questions are made by me. All of PYQ. Okay. So what they are asking you, they are only asking you partition function, nothing else. But in this case, finding a partition function will not be that easy, because there is a coupling term. Okay. So let's begin. So when I start finding partition function, first I need to deal with this momentum thing. So do you all agree for momentum, this will be the partition function? This you all agree first? If I अभी तक कितने क्वेश्चंस किए? In all of them, that the same thing we are getting. Right? Now we need is a position. इसको solve करना is important. Rest is simple. इसको solve करना is important. So let's solve. So if I write the integral, so you will have e की power minus beta h. So I put the value of h, basically this part, right? And then there are two parameters, q1 and q2. You can call it as q1, q2, you can call it as x, y, anything. ठीक है? तो अगर आप q1, q2 में ही रख रहे हैं, तो आप इसको, since the Hamiltonian is given in q1, q2, my integral will also be in d. So basically यहाँ मैं लिख सकता हूँ dq1 into dq2. That is what I need to solve. The thing is, how do I solve it? This is not easy. How do I solve it? Trick number one. Not trick, it's not a trick, it's a very deep concept of Gaussian integral. First, split this term. 1 by 4 q1 q2 can be written as 1 by 8 q1 q2 plus 1 by 8 q2 q1. Same ही बात है, it's the same thing. ठीक है? 1 by 8 xy, 1 by 8 yx is the same thing. ठीक है? That is why what I have done is q1 q2 into q2 q1, so that you can see the things better. So that is what I have written here. And this is q1 square, this is q2 square. Does this gives you a feeling of matrix where this is 1, this is 1, this is 1 by 8, and this is also 1 by 8. Do you all got the feeling of matrix? Yes. This is a matrix. Now we need to compare with our known result. What is the known result? The known result, or a general formula, is integral is going from minus infinity to infinity. Not one integral, two integral. In this case, there are two integral, right? So dq1 into dq2. In general, I have written as dnx, or you can even write it as, in simple terms, dq1 into dq2. Okay? Don't get confused here. Exponential की power minus half x transport into a into x. Okay? X transpose into a into x. Now इस चीज को समझते हैं. Let's understand this thing and let's compare it with this. So no, it's nothing. If I do something like this, q1 into q2 multiply by 1 by 8 into 1 by 8 into q1 into q2 equals to, again, q1 into q2. Then I multiply first row, first column. That gives me q1 plus q2 by 8. Then first row, second column. Sorry, first row, first column, and then second row, first column. That will give me q1 by 8 plus q2. And if I multiply this with this, do you think I will get this answer only? If I multiply this with this, do you think I will get this only? Yeah, क्या बोलते हैं? Right. So comparing this thing with this thing, let's compare both. X transpose. What was X transpose? Q1, Q2. What are my parameters? My parameters are Q1, Q2. And what is X? X is another matrix which is Q1, Q2. So this is a row matrix, this is a column matrix. And then A matrix is my important matrix. This is my important matrix. How do I write this important matrix? So Q1 ka square term is here, Q2 ka square term is here, Q1 Q2 term is here, and Q2 Q1 term is here. That is why you see I in the very beginning I split into Q1 Q2 and Q2 Q1 part. Can you tell me what is the difference between this and this? There is small difference. There is one constant ka difference. What is that? Can you tell me that? Half. You see there is a half here. but in this case you don't see any half outside. You do not see any half outside. So I need half outside. I need half outside. If I take half outside, do you think my A matrix, which was this, will actually become this? I need to take half outside. Okay. So half outside का मतलब होता है 1/2 and then multiply by 2. So if I divide and multiply by 2, in order to compare my integral with the general integral, all I need is half only, another half only. So multiply by 2 and divide by 2. So if I multiply by 2, what will this matrix become? This matrix become 2, 2, 1/4 and 1/4. 2, 2, 1/4 and 1/4. ठीक है, तो let me simplify these things for you कि ऐसा इंटीग्रल आए तो आपको सिंपल वे में क्या करना है, rather than understanding every detail of it, in simple way what you have to do. देखो आपका हैमिल्टोनियन क्या था? आपका हैमिल्टोनियन था e की पावर माइनस बीटा k q1 स्क्वायर प्लस q2 स्क्वायर प्लस q1 q2 by 4 8 and q2 q1 by 8. ठीक है, I need half here. If I need half here, I have to multiply, divide by half. So this will be 2, this will be 2, this will be 4, this will be 4. Because if I multiply by 2 across, I get this. And then I make my matrix A. This is, now I can make my matrix A. So my matrix A will have beta k here. So this beta k here, constant term here. And then matrix 2, 2, 1/4, 1/4. I don't take this half because in my general formula, half is there outside. There is a half outside. That is why I do not take this half. This half I keep as such. Rest everything is my A matrix. So A matrix is beta k. And then this part of the matrix. So 2, 2. So this is 2, this is 2. This is 1/4, this is 1/4. Okay. Very quickly, can you tell me, this is you have. Now, next step. Now you have to find determinant of A. Determinant of A. So it will be beta square into k square. इसका determinant करोगे तो क्या होगा 4 minus 1/16 which will be beta square into k square 63 by 60 16. Everyone knows why I have done beta square into k square. ये पता है सबको? Yes, ये पता है ना सबको? देखो क्या करते हैं, डिटर्मिनेंट ये नहीं पता, 12th क्लास का कॉन्सेप्ट है बच्चे। ये देखो पल्लवी जी, ये क्या करते हैं, देखो ये बीटा के सबके साथ मल्टीप्लाई हो रहा है, 2 बीटा के बाय 4 बीटा के बाय 4 and 2 बीटा के, and I need to find its determinant. When you are finding determinant, you can either take common from the rows or from the column. So you take beta k common from this, so it comes out to be beta k. Similarly, you take beta k common from this, so you get beta k square. Or you can even use the general property. What is the general property? Determinant of any constant into matrix A is given by A square into determinant of A. And if it is 3/3 matrix, then it will be A cube into determinant of A. In this case, it's a 2-dimensional matrix, so it is A square into determinant of A. So basically, what I'm saying is that if you know the determinant of A, this thing, the determinant of this thing is 63 by 16. And you need the determinant of this entire thing. So what you need to do is you have to multiply by beta square into k square. This is a basic property. Last 12th property. So I have found a determinant of beta square into k. So basically, first step, from my Hamiltonian, I have found A. First of all, my matrix A. कैसे करेंगे? Nothing. Just take half common. Half को वही रहने दो. Keep half as such. And then find your matrix A. Once you have found the matrix A, find its determinant. So you have found the determinant. Now you are at the last step. So the last step is 2 pi under root of determinant of A. So you get 2 pi into determinant of A का अंडर रूट करेंगे तो आपको मिल जाएगा बीटा के अंडर रूट ऑफ 63 into under root of 16. So that is your general formula that you can see here. That is you can see here 2 pi n by 2 by mod of A. 2 pi, sorry, यहाँ पे you have 2 pi n by 2. Now what was n? N is 2, right? You have two parameters. No? You have two parameters. So if you put n2, So 2 by 2 is anyway gone. So that is why you have 2 pi divided by more under root of determinant of A. So under root of determinant of A, you have already found the determinant of A that you put here. So step 1, write your coupled terms like this. When do we use it? When you see that there is a coupling of term. You have q1 square, you have q2 square. If you had only q1 square and q2 square, you could have easily done this formula. Minus infinity to infinity e की power minus alpha x square into dx. यहाँ से आपको directly answer मिल जाता. But you also have some coupling term, q1, q2. So first you write it in this way, then you take half common and then you write your A matrix. Once you have your A matrix, find the determinant of A. Simple. Once you know the determinant of A, you simply find the formula 2 pi n by 2. Now n is what? 2-dimensional. It's a 2-dimensional thing. So 2 by 2 is gone, divided by under root of A. So this is your integral. So this is the final answer for your integral. Is this clear? This technique is clear. Yeah, everyone. Technique is clear, right? This technique can be used. थोड़ा मुश्किल है, little bit difficult. Many of you might have seen this first time. ठीक है, चलो. So this is the integral I have found. So now I have both the integrals. I had the momentum integral. Yes, this was my momentum integral. I have my position integral. So this is my position integral. Now all I need to do is multiply both of them together. And that is an end of your topic, continuous partition functions. Yes. I will stop here for 30 seconds. Yes. Any doubt? Okay. So before I begin this, I want to ask, and every one of you know the basic questions of partition function, that all of you know. If you have a basic numerical of partition function, let's say I give you 2 energy system and I ask you to do that. Anyone have a trouble in that? Let me know. Okay? Because I don't want to go in that territory. I want to go in a territory which you don't know. For example, continuous and this magnetic property thing. Yeah. Anyone have a trouble? Let me know that you are even bad in one simple revision के लिए we did already simple revision, but ठीक है. Simple, I think you might have known that. चलो बात करते हैं उसके लिए भी end में we will have a little talk. But let's begin with the second difficult topic of canonical ensemble. Today's lecture will be little bit heavy, तो डरो मत, लेकिन ये काम बहुत आएगा आपको CSIR Net में. This will help a lot. So very quickly we will summarize magnetic properties. ठीक है, तो have a notebook in front of you. I will say note down this formula, note down this formula, note down this formula. You keep on note downing the formulas. ठीक है, and we will understand the chronology in which the formulas are coming. ठीक है, canonical ensemble. Magnetic properties. Chalo. Consider a system of magnetic dipole. Number 1 system. So we will understand 3. Okay? Understand 3. Understand 3 systems. Number 1 system is very simple. You have a system in which we have a spin half particles. So you have spin half particles. Okay? Sorry. Spin half particles. Now when you have spin half particles, uska matlab samajh lo. What is the meaning of that? Spin half particle means S is half. S is half. Okay. There is no MS. Only S is there. When you apply magnetic field, so let's say you apply magnetic field. Now these particles have two options. Either this particle can align their spin in the direction of magnetic field, or they can align their spin in the direction opposite to magnetic field. In this case, we say MS is plus half, and in this case, we say MS is minus half. So when you apply magnetic field, another quantum number appears, and that quantum number is known as MS, magnetic spin quantum number. For both of this, spin is still plus half. Okay, spin never becomes 1/2 and minus half. S is never plus half or minus half. S is always plus half. When you apply magnetic field, a new quantum number appears, which is known as MS. MS is basically can be plus half or minus half, depending upon if you align your spin in the direction of magnetic field or your spin aligns in opposite to the direction of magnetic field. So it is like a two-state system. It is like a two-state system. You have two states possible, spin up, spin down. Okay? When you, and the energy of the system can be given by the formula. This is the energy of the system. Energy of system means, what is system? System means one spin. only one spin you have. Okay? Only one atom you have or only one electron you have. Energy is given by minus mu naught h. This is energy minus mu naught h. Mu is known as dipole moment. Dipole moment. And h is the magnetic field that you have applied. This is not Hamiltonian. This is not Hamiltonian. H is the magnetic field that you have applied. And energy is given by minus nu naught h. It means if your spin is aligned with the magnetic field, then the angle is, so basically nu naught h can be written as minus nu h cos of theta. So if both are parallel, theta is 0, and if theta is 0, energy is minus nu h, because cos 0 is 1, so energy is minus nu h. But if both of them are opposite, then theta is 180 degree and cos 180 degree is minus 1, minus minus cancels, and your energy is nu h. So your dipole can take two energies, or your particle, your spin half particle, in the presence of magnetic field. Until unless you don't apply magnetic field, it is sitting peacefully. But once you apply magnetic field, your system has two options. Either it can be in energy nu h, or it can be in energy minus nu h. Okay. When it is in energy nu h, it basically means both are, it is spin down. Basically ms is minus half, and when it is minus nu h, it means it is spin up, basically ms plus half. This much clear to all? Yes. Please note down this thing. Yes, clear, and please note down this. Yeah.
Sir, that energy is total energy, na?
What is total energy?
Like
एक ही तो एनर्जी है इसमें, इंटरेक्शन एनर्जी, और तो कोई एनर्जी है ही नहीं.
okay, there is no any such kind of electric field.
No, no.
So okay,
Dipole in a magnetic
nothing.
field only has a magnetic energy, nothing
Yes,
else.
yes.
Okay, moving on. Can we move on? Yes. Writing down this, you have done. लिख लो, जल्दी से लिख लो. Partition function. How do you write partition function? If you know the basics, बताओ फिर. If you know the basics, how do you write partition function? E की power minus beta ei. Okay. So can I write minus beta nu h plus e की power minus beta minus nu h e की power minus beta nu h plus e की power plus beta nu h. क्या ये सबको समझ आ रहा है कि how did I write my partition function? Because two energies are possible. One was minus nu h and one was plus nu h. Okay, is it clear to all of you how did we wrote partition function for a simple discrete energies? Because now it is not continuous energies, we have discrete energy. One energy is minus nu h, one energy is plus nu h. बताओ भाई इसको कैसे लिख सकते हैं in terms of sine hyperbolic or cos hyperbolic? But how can I write it? जल्दी जल्दी. Cos hyperbolic or sine
cos
hyperbolic? Cos hyperbolic beta nu h. कैसे? सबको ये पता होना चाहिए. Cos hyperbolic theta is known as e की पावर theta plus e की पावर minus theta. इसके साथ 2 भी तो लगेगा. You have to multiply by 2 also, right? Divide by 2. Sin hyperbolic theta is written as e की पावर theta minus e की पावर minus theta by 2. Sin theta is known as e की पावर iota theta minus e की पावर minus iota theta divided by 2 iota. Similarly, cos theta is written as e की पावर iota theta plus e की पावर minus iota theta by 2. ठीक है, there is no iota here. You don't see any iota here. So I cannot write in terms of sine and cos. I can write it in terms of cos hyperbolic, sine hyperbolic. Basic revision, everyone. So you can write your partition function as 2 cos hyperbolic z. Basically beta nu h. And for n particles, all you need to do is raise to power n. Now you have partition function. Can you find free energy, Helmholtz free energy? Yes. I will not do it for you. You can do it. Right? All you have to do is use the formula, you find Helmholtz free energy. Can you find entropy? Because once you have Helmholtz free energy, you can find entropy. Differentiate. Can you find average energy? Yes. You can even find directly average energy minus curly by curly beta into log of z. So average energy you can find. So these three things, all of you can find. Yes, yes, no, yes, no. Quick. Yeah. The recipe I gave you, you practice it out, you find out. What is the thing that you need to understand? Magnetization. That might be new for you. You also need to understand what is magnetization, and you also need to understand how to find it. Magnetization basically means total dipole moment per unit volume. Total dipole moment, what is the meaning of that? So let's say before applying magnetic field, one spin was like this, another was like this, another was like this, another was like this. Every spin had a magnetic moment. Every particle had the magnetic moment, but the total magnetic moment was zero because everyone was random. Now you applied the magnetic field. You applied the magnetic field. Now you see the spins got aligned. All the spins got aligned. Some of them might not get aligned because it's not a perfect. Can you tell me why some of them does not get aligned? What is the reason which is stopping them from aligning?
Thermal
Random,
energy.
sir.
Temperature. Yes, because temperature wants to keep things random. So we have both. We have magnetic field as well as temperature. So there is a balance between them. So some of them will get aligned and some still will not be aligned. Hence, now our magnetic total dipole moment will not be zero. Total. In this case, the total dipole moment was zero because everyone was random. In this case, there is some order. There is not full disorder is not there. There is some order is there. That is why you have some total dipole moment. Total or average dipole moment. You can find average dipole moment. So average dipole moment you will have. And if you divide it by total volume, the total volume of the system, you will get magnetization. And the formula for magnetization is given by minus curly A by curly H. H is the magnetic field. You already know A. You already know A. And if you differentiate this with terms of H, you will also get magnetization. Yes. Clear? So please note down this formula for magnetization. Other formulas you already know. ठीक है? Magnetization का एक जो new formula has came, please note down. So I want all of you to do this maths once, okay? So when you are revising these notes, start from the partition function, find all the physical quantities once, do these differentials once. So that because in exam, they are directly asking you entropy, momentum, magnetization, these things they are directly asking you. Okay, now comes specific heat. Specific heat you all know. Specific heat is average energy divided by temperature. Divided by temperature means differentiate with temperature. Average energy you have already calculated. If you differentiate with temperature, you will find your specific heat. So specific heat also you can find. Okay. I want to go to important graphs. If you are all okay till this point, I will go with the graphs. Yes. Till this I can mark tick. Okay. Revising. We are revising. We are not covering the syllabus. We are revising. Important curves. There are some important curves. Without thinking too much about it, we will understand it. One is how does entropy changing with temperature? So what is it? Again, let me describe the system for you. So we have a system in which you have many spins. Now spins can either be up or down. Okay. So in this kind of system, how does your entropy changes with temperature? Okay. So that is the question here, right? So entropy changing with temperature gives you something like this. So why I am saying that? If you are at a zero temperature, you have to understand the two extremes of this graph. If you are at a zero temperature, so if the temperature is zero, means all of them are aligned. All of them are spin up. Spin up, spin up, spin up, spin up, spin up. How many ways are there to do this? Only one way is there to do this. In how many ways you can put all of them in the same direction? There is only one way. All of them are facing in same direction. So what is number of microstates? 1. If the number of microstates is 1, what is the entropy? Entropy is given by K log of sigma. So entropy is 0. Entropy is 0 means no randomness. If your temperature is 0, all of them are aligned in one direction. It means there is no randomness. It means your graph starts from 0. Okay. What if you have very high temperature? Very high temperature means there is no complete randomness. Complete randomness. Complete randomness means how many possibilities are there? So the first particle can have two possible directions. Second particle can have two possible directions. Third particle can have two possible directions, and so on. Since there are n particles, so total number of microstates will be 2 की power n. So your entropy will be k log of 2 की power n, which will be n k into log of 2, and that you see is a constant number. That is why you see at a very high temperature your graph becomes constant, and it is going for log of 2. Okay, log of 2. So is this graph clear? It starts from 0, entropy increases, and it ultimately becomes constant. Is the graph of entropy clear? Repeat is, if you are at 0, if your temperature is 0, we will repeat, don't worry. If the temperature is 0, all of them are aligned in the same direction. Okay? They have to align in the same direction because there is no temperature which is making them random. So there is only one way, because up, 1 multiply 1 multiply 1 multiply 1 means only there is one possibility to make them all looking in one direction. Means there is no randomness. Entropy is 0. So here you have entropy 0. But if the temperature is very high, every spin has two possibilities. First spin, let's say first particle can either be up or down. So there are two possibilities for spin 1. Then again spin 2 again has two possibilities. Particle 2 again can have two possibilities. Particle 3 can again have two possibilities. So how many are the total number of properties? Total number of possibilities. 2 to power n. And how do we find entropy? Once we know the number of microstates, S equals to k log of sigma. If you put 2 ki power n, n can be coming forward, n k into log of 2. So this is constant. So ultimately at a very high temperature, the entropy becomes constant. You see, it is becoming constant. Okay. So entropy starts from 0, but ultimately at high temperature, it becomes constant. So what is this constant value? Nk log of 2. And what is this value? 0. Now clear entropy graph, everyone? So this is complete orientation. This is complete randomness. So when the temperatures are high, the randomness will increase. When the temperatures are low, orientation will increase. Perfect? Yes? Perfect. So in this case, can you remember now the entropy versus temperature graph? Simple. That is the thing which I am asking for. Okay. Now let's go for average energy or kiska graph? Average energy versus temperature graph. Average energy versus temperature graph. So average energy starts from a negative number and it goes towards, okay, why it's a negative number? First of all, at 0 temperature, why it's a negative number? So let's think from the previous graph. In the previous graph, when I was at 0 degree Kelvin, all my spins were up, basically looking in the direction of magnetic field. Full orientation was there. There was a full orientation. No randomness because temperatures are not there. So if there is full orientation, and we already learned, then when magnetic field and spins are in the same direction, the energy is minus nu h for one spin. And if there are n spins, you multiply by n. So it means at 0 temperature, what is the energy? Minus nu nh. Minus nu nh. Can you tell me at infinite temperature, what will be the energy? What will be the energy? PK, this is what, okay. So what you said is actually very stupid thing, okay? It is not about magnetic field being up and down. How do you define up and down? It is being if magnetic field and magnetic movement are in same direction or are they in opposite direction. It is not about up and down. It is about magnetic field and magnetic movement being in same direction or being in opposite direction. Okay? So we are not defining north, south, up, down. In whatever direction you apply magnetic field, that is considered as up, and in whatever direction you are applying magnetic field, uska opposite will be down. Okay, good. Okay,
At a
tell me.
higher temperature, all the
The
magnetic
energy
field
approaches to which number?
is 0 because
Zero.
I feel key
0, na?
because it's going to randomize again, na, for overall.
Yes. So when you are at a higher temperature, there is a randomness. Randomness means कंप्लीट रैंडमनेस। रैंडमनेस का क्या मतलब होता है कि 50% विल बी स्पिन अप एंड 50% विल बी स्पिन डाउन, वही होगा ना फुल रैंडमनेस, because both of them are equally probable now because randomness is there. So half of them will be down, half of them will be up. If half of them is down, it is energies plus nu h, and if half of them is up, then it is energies minus nu h. N by 2 half particles, n by 2, so the total average energy is 0. So your graph starts from a negative energy and it ultimately reaches 0 at a very high temperature. Okay, so when you are at complete randomness, half of your particles are in the direction of magnetic field, half of your particles are opposite to the magnetic field. Basically, that is what a randomness means, right? Half of the times you get heads, half of the time you get tails. It means it's a random, perfect randomness. And if you are getting heads every time, that is perfect orientation. So entropy was starting from 0 and then becoming a positive constant. Energy is starting from a negative number and becoming 0. Yes, yes, here, clear. क्या बोलते भाई? ये दो ग्राफ, any of them can come in exam. सीधा ग्राफ पूछेंगे आपसे, directly they will ask the graph. Okay. Okay, next. Magnetization. Magnetization, again the simple logic. When you are at a low temperature, full orientation. Full orientation means all of them are in the same direction. If all of them are in the same direction, it means complete magnetization. What is the dipole moment of each spin? Nu, 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 nu. So what will be the total dipole moment? Total dipole moment will be nu into n. Total dipole moment will be nu into n. And if you divide by volume, you get magnetization. Magnetization. There was a full magnetization when your temperature is 0 because all of them are looking in the same direction. And there will be no magnetization when the temperature is very high because half of them will be looking up, half of them will be looking down. So the total magnetization will be 0. So again, the graph is something like this. You start from positive number and you end up at 0. What do you say? Clear? Third graph clear?
What is epsilon, sir? यहाँ पे epsilon क्या है?
What is?
KT by epsilon, you have taken the scale as a in the proportion of KT by epsilon in each graph.
What is KT by epsilon? छोड़ दो यार, वो बुक के ऊपर डिपेंड करता है कि कौन सी बुक से ग्राफ लिया है, वो सब छोड़ दो.
Okay. It's just magnetization versus temperature. We have to look at the.
Yes. M versus T. Yes, that's all. Okay, chalo. Okay, then these are also the interesting graphs. Specific heat versus temperature. Specific heat versus temperature graph. I will not go in detail of theory, although I can go, but graph only you keep in mind that specific heat first increases then decreases. Okay, first increases then decreases with temperature, and this we have already covered. So that this is just a repeated graph. I am basically okay, from the graph of energy you can understand. So this was the graph of energy. You remember we just did the graph of energy. The graph of energy was this. So how do I explain? So you see, specific heat is a differentiation of energy, which basically means it is a slope of energy versus temperature graph. Specific heat is a slope of energy versus temperature graph. So initially, if you see, slope was 0. If you see clearly, the slope is 0. That is why you start from 0. Then you see the slope is increasing. So slope is increasing. Then you see the slope starts to decrease. Initially, the slope was increasing and then slope starts to decrease. Hence, the specific heat was initially increasing and then it starts to decrease. Clear? From this graph, is this clear? Yes? Ultimately, it becomes it. Yeah? So this you don't have to remember. For CSIR net, there is no need. It is important for gate. For CSIR net, no need for this. Okay? This equation is not needed. Okay? Now, last graph, entropy. Entropy also has a similar, it has a very perfect parabola kind of situation. Initially, the मतलब कि entropy तो we already covered, right? कि नहीं किया? Entropy कर लिया ना starting में. First graph was entropy, right?
That was versus temperature, sir.
This is something else. This is something else. इसको छोड़ दो.
Sir, energy.
हाँ, this is for Schottky defect. ये ग्राफ आपको अच्छा entropy versus energy है ये. सॉरी, हाँ,
Yes, sir.
दिस
Negative
ग्राफ
and
इज फॉर
positive.
इंट्रोपी वर्सेस एनर्जी। वो ग्राफ था इंट्रोपी वर्सेस टेम्परेचर। सो इंट्रोपी वर्सेस टेम्परेचर का ग्राफ कैसे किया था हमने? दिस वाज अ ग्राफ। बट इफ वी हैव इंट्रोपी वर्सेस एनर्जी ग्राफ, देन इट इज अ परफेक्ट पैराबोला, ठीक है, लाइक अ हाफ सर्कल, ठीक है। तो ये कुछ ग्राफ्स हैं, फैक्ट स्टेटमेंट काइंड ऑफ, बिकॉज दिया हुआ है। एकाद पीवाईक्यू यू विल सी दैट दे आर आस्किंग यू द ग्राफ आल्सो। तो अगर आप ये 4 और 5 ग्राफ्स विल कीप इन माइंड, आपको हेल्प हो जाएगी। एंड अगर नेट में नहीं हो रही, गेट में, तो 100% यू विल हैव अ बेनिफिट। इन माय गेट रिवीजन क्लासेस, इन ग्राफ्स के ऊपर वी विल हैव अ ह्यूज डिस्कशन, ठीक है। ओके 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 ओके, लेट्स गो ऑन फॉर नेक्स्ट, लेट्स गो ऑन फॉर नेक्स्ट, ठीक है। ओके, नाउ वी हैव टू अंडरस्टैंड द पैरामैग्नेटिज्म। पैरामैग्नेटिज्म, इसके अंदर वी ओनली नीड टू डू basically two theories are there in paramagnetism. One is known as classical theory, one is known as quantum theory, ठीक है। classical theory and quantum theory of paramagnetism. So let's understand that, let's understand these theories, and that will basically give you a good understanding। करना चाहिए for CSIR net। ठीक है, आई थिंक वी कैन स्किप दिस पार्ट। इसको मुझे नहीं लगता CSIR नेट में इंटरेस्टिंग है। वी कैन डू द क्वेश्चंस।
I think पूछा है सर PYQs में
क्वेश्चन करते
देखे
हैं,
थे मैंने
वी विल डू क्वेश्चन,
क्वेश्चन
थ्योरी को छोड़
पूछा है
के
काफी।
क्वेश्चंस पे आते हैं। सो लेट्स अंडरस्टैंड दिस विद द क्वेश्चंस। सीधा क्वेश्चन हम वी कैन डू, ठीक है। 30 minutes आई विल टेक मोर, so today we will extend the class little bit, 30 minutes I will take more, so let's extend it. So we have a two-dimensional box in a uniform magnetic field B. Listen to me very carefully, we will do question very systematically. A two-dimensional box in a uniform magnetic field B contains n by 2 localized spin half particles with magnetic field nu and n by 2 spinless particles which do not interact with each other. So in my sample, there are n by 2 spin half particles and there are n by 2 zero spin particles. Okay. What is the average energy? So for average energy, I need, first of all, I need is a partition function. So let's write partition function. Okay. Let's write partition function. So how do you write partition function? So this is Z. This is Z. It is given by e की power minus beta ei. E की power minus beta ei. ठीक है. Now, what are the possibilities? How do you write? If it is spin half particles, let's say if it is spin half particles, then you have two possible energies. Either the spin half particles are aligned in the direction of magnetic field or they are aligned opposite to the magnetic field. So the partition function becomes e की power beta nu h plus e की power minus beta nu h. That we already know what we call it as 2 times cos of hyperbolic into beta nu h. And if it is spin zero, मतलब spin ही zero कर दिया, means magnetic moment ही if I make it zero, तो my energy will also be zero. So then my partition function will be e की power 0, which is simply 1. Right? Because what is energy? Energy is given by minus nu dot h. If spin is 0, magnetic moment is 0. Magnetic moment is 0 means energy is 0. If energy is 0, e की power 0 is given by 1. So partition function for spin 0 particle is 1. Partition function for spin half particle is given by this. ठीक है? That you can clearly see here. ठीक है? So okay, let's find it average energy for this. You can easily find average energy. कैसे करेंगे? Minus curly by curly beta log of z. Minus curly by curly beta log of z. तो क्या करेंगे सर? करेंगे अगर log of z, तो if you will solve this calculation out, you will get this. This is the average energy that you will get. ठीक है? Can you tell me what will be the average energy for spin zero particles? What will be the average energy for spin zero particles? 0. क्योंकि जिनके पास स्पिन ही नहीं है उनकी मैग्नेटिक फील्ड में क्या ही एनर्जी होगी? कोई एनर्जी नहीं होगी। तो दिस इज द आंसर दैट यू गेट। Okay. Only thing that you need to keep in mind is then when you are finding the partition function for n particles, you don't raise the power by n, you raise the power by n by 2, because there are n by 2 particles having spin half and n by 2 particles having spin 0. That is why you see n by 2 here and not nothing else. Okay. So that is going to be your answer. Okay.
सर
Another
अगर
interesting, बताओ.
सर अगर इफ वी हैव डन लाइक कि पार्टीशन फंक्शन को ऐड करके फिर एनर्जी निकालते तो गलत हो जाता ना.
Sorry.
पार्टीशन फंक्शन को हम स्पिन पार्टिकल्स वाले को और स्पिनलेस वाले को अगर हम उनका पार्टीशन फंक्शन निकालते एंड देन वी हैड एडेड इट और फिर हम एनर्जी निकालते टोटल एनर्जी, तब वो गलत
नहीं
आंसर
सर,
देता,
वो ऐसे
राइट?
नहीं कर सकते. ऐसे थोड़ी आप ऐड कर सकते हो दोनों पार्टीशन फंक्शंस. नो नो, यू कैन नॉट ऐड लाइक दिस कि इसका पार्टीशन फंक्शन और इसका पार्टीशन
ओके.
फंक्शन यू कर भी लो.
हाँ.
अगर कर भी लो तो तब भी नहीं आएगा. आई थिंक ये नहीं कर
नहीं
सकते
आएगा
आप.
सर, नहीं आ रहा.
यू विल
नहीं आ
नॉट
रहा.
डू दैट यू कैन नॉट डू, डेफिनेटली नॉट. ठीक है, चलो.
बट सर वो मल्टीपल पूरा जीरो दे देगा बिकॉज गोइंग टू बी मल्टीप्लाइड.
सॉरी, क्या मैं समझा नहीं आपका.
Oh no,
What
sir.
do you
The
say?
mathematics is itself coming out to be not comparable with the actual answer. So
नहीं, पार्टीशन
incorrect.
फंक्शन यू कैन नॉट ऐड, ऐसा नहीं कर
Yes,
सकते.
sir.
यस यस. ओके ओके, दैट इज ओके. ओके, ठीक है, दैट इज फाइन. मैग्नेटाइजेशन हो गया. Okay, let's do one classical system itself. Just last one problem I will do and then we will end. Just one more problem, if you understand, it will be a good idea. Then we will, then I will just revise few more things and then it will be end. So classical system को थोड़ा सा समझ लेते हैं. How is classical system different from quantum system? What we did right now was a quantum system. Why it was a quantum system? Because I said that you have a magnetic field and your magnetic moment can either be spin up or spin down. Basically, discrete possibilities were there. Discrete possibilities were there. Spin up, if it is spin up, the energy is minus nu b, और इसको h बोला ना हमने, nu h or plus nu h. So this was the discrete possibilities. But in the classical model, your angle between the magnetic field and dipole moment can be anything. It does not needs to be aligning in the direction of magnetic field or opposite to the direction of magnetic field. This restriction is only in quantum mechanics. Only quantum mechanics says that your magnetic moment can either be in the direction of magnetic field or opposite to the direction. Discrete possibilities, only two discrete possibilities are there. This is the rule of quantum mechanics. This is not a rule of classical mechanics. Classical mechanics says that, okay, if this is h, then this is nu. This nu can take any angle theta going from 0 to 2 pi. Do you understand this? What is the difference in classical and quantum? So energy is, if I talk about, energy is what? Minus nu dot h. So it will be minus nu h cos of theta. So is this energies discrete or continuous energies? Now you tell me.
Continue.
Discrete energies or these are the continuous energy system? It is definitely going to be the continuous energy system. Okay, okay, perfectly fine. I hope that this thing is clear. Okay. So when we have a continuous energy system, how do we write the partition functions? So we write our partition function something like this: integration minus beta h, or Hamiltonian basically. So this is Hamiltonian, okay? H dot is a Hamiltonian, don't get confused, okay? It's a Hamiltonian, or energy, okay? This is Hamiltonian or energy, beta h naught, and then you have integrals here like dp, dq, ds. But the thing is, in this case, your energy is not depending upon x, it is not depending upon momentum, it is depending upon angles. So we have to treat it in terms of a spherical polar coordinate system. So can you tell me, how do you write total volume in spherical polar coordinate system? Assume radius is 1.
Sin square theta and then the coordinate
Sine
d phi.
square. Is it sine square? Yes.
Sin theta only, sir.
should be there.
D
dr dθ d
dr छोड़ दो, रेडियस तो नहीं है इसमें, सिर्फ एंगल्स की बात, एंगुलर पार्ट ओनली. सो व्हाट विल बी दैट?
no, only the azimuthal and
d theta into d phi. So that is what I multiply sin theta into d theta into d phi. And if you solve this up, d phi integral I can separate. D theta integral I can write like this. So I put this value. So you get beta nu h cos theta into d theta. Theta goes from 0 to pi. Phi goes from 0 to 2 pi. This is how you simplify. In terms of classical model. Classical model की बात कर रहा हूँ. You can obviously do quantum model, which we did in the first part, in which only two possibilities were there. Theta can only take two values, 0 or 180. In this, theta is not taking two values, it is taking many values. That is why you have to go for this. Okay? So this gives you 2 pi. And can you solve this out? Can you try to solve this out? What do you say? Can you try to solve this out? कैसे करेंगे बता सकता है कोई मुझे? यहाँ पे sin theta भी है. Sorry, sin theta is also there. Sin theta into d theta. Can you tell me how do you solve this integral? There is a very simple step. What do you do? Put beta nu h cos theta equals to t. So beta nu h sin theta d theta equals to dt. So sin theta d theta becomes dt by beta nu h. So you put it here. ठीक है, e की power t into minus of dt by beta nu h. ठीक है, एंड देन इसका इंटीग्रल तो आपको पता ही है, e की t का इंटीग्रल इज सिंपली e की t, and t की पावर you can put as b nu h cos theta, and then you can put the limits going from 0 to pi and minus beta nu h. ठीक है, you put the limits, you get your partition function. So क्या ये हो जाएगा? Will it be done? Yes. Partition function कैसे निकालना है, you understand in this case? Clear? Okay. Once you know partition function, what are all the things that you can find? बताओ मुझे जल्दी से. What are all the things that you can find? Average energy. What else you can find? What else you can find? A. Once you have A, you can find entropy. Once you have entropy, what else you can find? Entropy हो गया. What else you can find? सब कुछ निकाल सकते हैं जो जो आपको चाहिए. Chemical potential, magnetization. ये पूछा है. In one of the PYQ, they have asked magnetization, pressure, so on. So that is the only difference between quantum system and a classical system. Partition function of a quantum system, I explained you. It is coming out as 2 times cos of hyperbolic beta nu h. In this case, the partition function, that was the very first thing which we did, that how to find the partition functions for classical systems in which the energies are basically continuous. Okay. So I think this is okay. But again, you will be needing 1 or 2 hours to revise these notes out. I will provide all of these notes. Try to drive all the formulas once. Even if you just try to drive the formula once, or even if you spend 1 full day on canonical ensemble, is it worth? Yes. From today 7 p.m. to tomorrow 7 p.m., 6 p.m., if you spend entire day on just canonical ensemble, it will give you at least more than 7 marks, 100%. And if you only do all the things which are there in the notes, that's all. This equation कैसे आया, ये equation कैसे आया, ये कैसे आया. Any equation like Langevin function, beta function, you see here, that you can skip. For example, here I have discussed some things like these. These you can skip. इसकी आपको जरूरत नहीं है. These you can skip. These you can skip. Skip. These you can skip. Otherwise, you can do all the things which we covered. And no, basically, in the end of every lecture, there are few questions. Mainly, if you do that question, that will be enough. Okay. So one thing that we will keep in mind is recipe. Once we have partition function, how to find other things. Second thing that we will keep in mind, which CSIR Net loves to ask, is how to find partition function for continuous energy system. Third thing that we will keep in mind is basic part, मतलब basically magnetism के अंदर 2 theories are there. Classical theory, उसके अंदर partition function कैसे निकालना है, and then quantum theory, उसके अंदर partition function कैसे निकालना है. We found the partition function for quantum, then we found the quantities, then we look at the graphs. This entire thing we will do. Then we find the partition function for classical system. I think for classical system, only the partition function and magnetization. So for classical system, what is partition function and what is magnetization? If you just do these two things, that will be enough. But for quantum system, we did all the parameters and we also look at the graphs. So for quantum system, all the parameters are important. For classical system, only these two parameters, if you know how to calculate, is enough. Okay? And then once these three things are done, then I will provide you one note in which we have a basic questions of canonical ensemble. Okay, there are 2-level systems, 3-level systems, and even if you don't want to look at that PDF, I will put the PDF of last 5 papers. In last 5 papers, what are the questions which are asked from canonical ensemble? Just do those 5 papers. मतलब उसके अंदर I have a questions कि this is the questions 10-15 questions which are asked in last 5 papers. Only do those questions in last 5 papers canonical ensemble में से these are the questions which have came. I have already provided you in with the links. You see, I provided you in your group links कि उसके अंदर one of the link is canonical ensemble के last 5 papers. That's all. So you will revise whatever we have covered today, what we have covered, recipe, then how to find continuous partition function, then magnetic system. Magnetic system में 2 things, classical and quantum. Quantum in detail, classical only partition function and magnetization. And in terms of basic canonical ensemble, only last 5 papers. That's all. ठीक है, ये काम आपका आज रात में ही हो जाएगा. Tomorrow morning you can start something new. Any doubt here? ठीक है. And again, let's keep the groups activated. If you have any doubt in your study, keep asking in the group. I sleep around 3-4 a.m. So till 3-4 a.m. I am there to solve your doubts. So keep the group open. I will help you in the groups also. Okay, sure. Yes. So this was a little difficult to summarize in 90 minutes. That is why we increase the speed little bit. Otherwise, for other topics, we won't have such